Hello, my name is Esmeralda Morales. This is my project for Math 134. For the first question, it asks for us to provide some information on the data set that we chose and to also give a picture of the first 10 values. The data set that I chose is name, sample, college data, and the column I chose on this data set was stat reading, 75%. The size of the column itself in values is 197, and the units are in points. Here's the picture of the first 10 values, and here is the website link, so that takes you directly to that data set itself. For question 2, it asked whether it was a sample or population, and well, it was pretty self-explanatory. In the title itself, it stated that it was a sample. For question 3, it asked for us to do a 5-number summary and to provide a picture of a one-stat variable or a previous lab we had done. I decided to do lab 19, so I inputted the values and it gave me, as you can see, my values, which were 197, my minimum, which was 400, my Q1, 530, my medium, 560, my Q3, 610, my maximum, 770. The 5-number summary itself is practically the same thing. As I moved on to question 4, it asked for the evaluation of the mean, the variance, and standard deviation, and a picture of a one-stat variable, which I have provided, as you can see. And of course, you can also see that the column states stat reading 75%. And here is my mean with the proper formulas, my variance, and my standard deviation. And as I moved on for question 5, it asked to evaluate several things. The first was the IQR, which I provided the breakdown for each one so that it made it easier to input into the formula and easy to follow. So my IQR ended up being 80, and as I continued on, it asked to evaluate the z-score for the minimum and the maximum value. At this point, I did the minimum first, which was 400, as previously stated up top, and of course my mean and my standard deviation, and I used the proper formula. So the z-score for the minimum value is equal to negative 2.54. The maximum x value here is going to be 770, and the z-score for the maximum value is equal to 2.82. Stop it. As I continued on, it asked to evaluate the usual intervals using the mean and the standard deviation, which here I have a sample, so therefore it is my x bar minus or plus or minus 2 times my standard deviation. Once I inputted the proper formula, my outputs or my answers were the usual intervals is 437, 713 points using the mean and the standard deviation. As I continued to evaluate for D at this point, the usual intervals using the lower and upper fences. Once again, I have provided what the IQR, the Q1, and the Q3 are, so I can make it easier to follow with the formula has been given for the lower and upper fence. And my answers are as follow. The usual intervals is 410 for the lower fence and 730 for the upper fence. This is in points, and of course using the fences. For 6, it had provided for, for 6, it had asked for us to provide graphs. Since I had some type of difficult column due to the numbers, I couldn't use a stem plot, so I needed to use a QQ plot instead. The following is a bar graph with the 5 classes, and then a whisker plot and a dot plot. moving on from there, question 7 wanted us to create either a cluster or a stratified sample that contained a total of 20 values. So I needed to use a stratified sample because the data set is small for a cluster sample with only 197 values. The steps for the stratified sample are as follows. So I did 2 groups. 1 through 98 was my first group, and then 99 through 97 was the second. As you can see, I gave you guys the code that I ran on the calculator itself, and this was my code output, which provided the sample from that. And then the second group, I also provided the code that I ran on the calculator, as well as the code output and the sample itself. And once I moved on to question 8, it had asked for me to do a Google Sheet file with the information that I have basically gathered from doing the stratified sample. So let me show you guys that. Which is right here. And as you can see, there's my entire data set. And on the side, you see the ones that have been picked out, which are the samples. Those are the codes, sorry. And then the samples got pulled. And there's your organized sample itself. Now, I did provide a email, or not an email, I'm sorry, a website link to that. For 9, it had asked to evaluate the mean, variance, and standard deviation for the sample obtained, which was the organized sample that I had. And there is my mean, my variance with the proper formulas and the standard deviation. And I decided to use Lab 19 to put in for the mean, the standard deviation, and the variance for that sample. And moving on to question 10, oh sorry, I moved too fast. It had asked for us to run a one stat variable, which I did, and then the sigma is equal to the 61.08704.855, approximately 61.0870 after rounding, and here is the calculator for that. For question 11, it is asking me to do the evaluation of the upper bound for the population of the mean. And it's telling me that the value of the z is a critical value from a 90% confidence interval for my population mean. So, that being said, it also told me that I needed to use the sigma that I have already found in question 10, which was at 61.0870. And as you can see, I provided my discoveries so that they can be properly inputted into the formula itself. So once I did the calculations, the value for the upper bound for the population mean is 597.82. As I continued on for question 12, it asked me to do a whisker plot to estimate the distribution shape. And to my conclusion, the distribution is likely bell-shaped since the IQR is near the medium and the possible outliers are maximum and minimum scores. Moving on to 13, it had asked for me to use either the empirical rule or the Chevy-Chase theorem. I I had decided to use the empirical rule due to the bell-shaped distribution estimation of my data graph. So using the proper formulas, I inputted the information that I have already previously gathered. And by the empirical rule, I have approximately 97.7% of the data within 3 standard deviations away from the mean and the intervals, 368.31, 782.19 points. For question 14, it had asked for me to create one confidence interval for the following of the mean, proportion, variance, or standard deviation. I chose the mean at a 90% confidence interval. As you can see, I stated it. I will use a 90% confidence interval, and sigma is not given. Therefore, I provided all the information for the values needed for my formulas, and my degrees of freedom, as you can see, are 196. My mean is 175.25. My value is 197. My standard deviation is 68.9809. My critical values are as follows: the 90, the alpha is 0.05. Once it's broken down by 2, it's 0.025. At this point, I use the applet T. My goodness, it's called the applet T distribution inverse calculator that was on week 10 for the class. And doing so, I was able to input the degrees of freedom and my 90% confidence interval, which gave me the t-score of 1.6527. I therefore rounded it to 2 decimals, which is t approximately is 1.65. And then I had my standard error formula. Once I inputted everything that where it belonged, I got 8.1092 after rounding, of course, to 4 decimals. Therefore, the 90% confidence interval for mu, using the proper formulas, turns out to be is 567.14, 583.36 points. I did a t interval. I'm off by 1 number at the end of both of those answers because of the way that I rounded for the standard error. Once I continued on, 15 asked me to basically create another confidence interval, this time with 80% for the mean, and it also provided error to be E equals 0.10 units from the population mean. Therefore, it was also telling me to use the minimum sample size, and I stated it that I was going to create, as you can see, I will use the minimum sample size to create a confidence interval of 80%, and S because sigma is not given. I once again provided my values. Sorry, I moved too fast. My values so that I can input everything correctly. And again, I use that applet graph to give me that information that I needed. And once I ran it with the 0.80% and the degrees of freedom, the t-score was 1.2859. I rounded it, and the critical value for t approximately turned out to be 1.29. And then using, of course, the proper formula because I had already previously stated up here that I was going to use the minimum sample size. I inputted the information and I got 6,000. I'm sorry. I think my audio went out right now. As you can see, come on, move. Oh, I don't know if it's, okay, it's on now. As you can see, I need at least 613,830.0 or more points to create an 80% confidence interval for the population mean. As I move on to question 16, it had asked for a claim and to do the following for the hypothesis test for the mean, which I decided to do for the mean again. And the claim is that the mean of the population is equal to 560 points. I will be testing this with a confidence level of 90%. Here is my claim, which is my mean equals 560 points. I'm stating the hypothesis, HO and H1. My critical values, which were at the 90%. And again, I use the applet to give me the t-score that I was needing. The critical values is t equals negative 1.65 as well as comma t equals or approximately 1.65, which is my mean, my value, my standard deviation. Now I ran my test statistics here, the proper formulas, and I inputted everything that where it belonged. My t ended up approximately equaling 3.10. The p-value here was 0.0022. I ran a t-test, and here is the information that I gathered from that. As you can see it on my calculator. Therefore, my conclusion to this all is reject HO since the test statistics of t approximately equals 310 is greater, or 3.10 is greater than the critical values of t approximately equaling 1.65. There is sufficient evidence to warrant rejection of the claim that the mean of the population is equal to 560 points. Thank you. I hope it was informative. Have a great day, y'all.